There is a place in the universe where everything we know stops working, not slows down, not gets complicated. Stops. Completely. The laws of physics are the same laws that govern every atom in your body, every planet in every galaxy, every force and particle and interaction that has ever been observed or measured. Those laws walk to the edge of a black hole and cease to function. What lies beyond that edge, we do not know. We have never known. And the closer science gets to finding out, the more terrifying the answer becomes. This is not speculation. This is not science fiction. Every entry on this list is drawn from peer-reviewed physics, from the work of the greatest scientific minds in human history, and every single one of them ends in the same place: a wall, a silence, an answer that isn't there. These are 10 things hiding inside black holes that science cannot explain. Number 10 are the singularity. In 1915, Albert Einstein published his general theory of relativity. It was the most precise, most tested, most successful theory of physics ever produced. It predicted the bending of light around massive objects, the existence of gravitational waves, the expansion of the universe itself. Decade after decade, every experimental test confirmed it. Then someone applied it to black holes. At the center of every black hole, general relativity predicts something called a singularity, a point. Infinitely small, infinitely dense. A location where mass is compressed without limit, where gravity becomes infinite, where spacetime itself curves without end. Here is why that is impossible. Infinity is not a physical quantity. It is a mathematical symbol for something that does not exist in reality. When a theory produces infinity as an answer, it does not mean the universe contains infinity. It means the theory has broken down. It means the equations have stopped describing reality and started describing nothing at all. The singularity is not a discovery. It is a confession that at the center of every black hole in the observable universe, our best theory of space and time collapses into nonsense, and we have no replacement ready. Every black hole in existence contains something we cannot describe, something we cannot name, something the most advanced physics ever developed cannot reach. That is where we begin. Number 9, the information paradox. In 1974, Stephen Hawking made a discovery that he spent the rest of his life trying to undo. He showed, through a combination of quantum mechanics and general relativity, that black holes are not truly black. They emit radiation of faint, thermal radiation produced at the event horizon, over vast timescales. This radiation drains the black hole of energy. Slowly. Inevitably. Until the black hole is gone. This became known as Hawking radiation. It was celebrated as a breakthrough. Then someone asked the obvious question: if a black hole evaporates completely, if it radiates away every last fragment of its energy until nothing remains, what happens to everything that fell in? Every star that collapsed, every planet that crossed the event horizon, every particle of matter that ever entered that black hole carried information. The precise quantum state of every atom. The complete description of everything it ever was. According to quantum mechanics, information cannot be destroyed. This is not a preference. It is a fundamental law. Information must be preserved somewhere, in some form, always. According to Hawking radiation, the black hole is gone. The information went with it. One of these statements is wrong. We do not know which one. Hawking himself proposed that the information simply disappears, that quantum mechanics at the edge of a black hole simply fails. Other physicists refused to accept that. The debate consumed decades. It produced proposed solutions of firewalls, fuzzballs, holographic encoding at the event horizon, and none of which have been confirmed. None of which are complete. Somewhere inside every evaporating black hole, the universe is doing something with the information of everything that ever fell in. We do not know what. Number 8 are the event horizon itself. The event horizon is not a surface. There is no wall, no membrane, no physical boundary you could touch if you crossed it. It is a mathematical threshold, the precise distance from a black hole's center at which the escape velocity equals the speed of light. Cross inward past that threshold, and light itself cannot escape. You cannot escape. Nothing can. From the outside, a person falling into a black hole appears to slow down as they approach the horizon. Gravity dilates time. To a distant observer, The falling body seems to freeze suspended at the edge forever, growing dimmer as light redshifts away, never quite crossing. From the falling person's perspective, they cross the horizon without noticing. No alarm, no sensation, no moment of crossing, just inside. Both of these things are true simultaneously. The same event, crossing the horizon, takes infinite time from one perspective and finite time from another. The same moment exists and does not exist depending on where you stand in the universe. General relativity insists both observers are correct. Both reference frames are valid. There is no preferred vantage point from which reality is being correctly observed. This is not a paradox we have resolved. It is a paradox we have agreed to live with. And inside the boundary of that paradox, for every black hole in the universe, something is happening that we are incapable of observing, incapable of testing, and incapable of explaining. Number 7. Time. Time does not pass at the same rate everywhere in the universe. Near a massive object, gravity bends spacetime. The stronger the gravity, the slower time moves. This is not theoretical. It has been measured in GPS satellites, in atomic clocks flown on aircraft, in the precise timing of signals near massive stars. The effect is real. It is continuous. It scales with gravity. At the event horizon of a stellar mass black hole, time dilation becomes extreme. At the event horizon of a supermassive black hole of the kind that anchor entire galaxies, containing billions of solar masses, the effect becomes something that no human intuition can process. For an observer frozen at the event horizon, held there by some impossible force, not falling at the entire future history of the observable universe, would play out in what feels like a finite period. Stars would ignite and die. Galaxies would collide and dissolve. The universe itself would cool toward heat death. All of it visible, all of it compressed. Inside the horizon, this effect does not simply continue. It inverts. Space and time exchange roles. The singularity is not a place you fall toward. It is a moment you fall toward. A moment in your future that you cannot avoid, cannot delay, and cannot escape the way you cannot escape next Tuesday. The end of the black hole's interior is not a location. It is a deadline. This is what the mathematics says. We do not fully understand what it means. Number 6. A spaghettification, and what survives it. As an object approaches the center of a black hole, the difference in gravitational pull between its near side and its far side grows without limit. This tidal force stretches the object, compresses it, pulls it into a thin thread of matter, atom by atom, until nothing resembling the original structure remains. This process is called spaghettification. The name sounds almost playful. The physics is not. Here is the question no one can fully answer. At what point, during that process, does the quantum information encoded in that object become unrecoverable? Every atom that is stretched and torn still carries quantum states. Those states must be preserved, or quantum mechanics demands it. But as matter approaches the singularity, as the curvature of spacetime becomes incomprehensible, as our equations break down entirely, the mechanism by which that information is preserved becomes completely opaque. We can describe spaghettification from the outside. We can trace the tidal forces mathematically. We can calculate the moment at which any given object would be torn apart. What we cannot calculate is what happens to the quantum signature of everything that was torn apart, where it goes, how it persists, whether it persists at all. The answer is hidden somewhere inside, and we have no way to look. Number 5. The firewall. In 2012, for physicists Ahmed Almheri, Donald Merrill, Joseph Polchinski, and James Sully, published a paper that broke something everyone thought was settled. They showed that if information is preserved during Hawking radiation, as quantum mechanics requires, then the event horizon cannot be the empty, unremarkable threshold that general relativity describes. Instead, it must be something else entirely: a wall of fire, a surface of extreme energy, burning at temperatures that would destroy any infalling object the instant it crossed. Not gradually, instantly. Nothing would reach the interior. Nothing would experience the calm descent that general relativity predicts. This became known as the firewall paradox. The problem is that the firewall cannot exist without violating general relativity, as specifically the equivalence principle. which states that a freely falling observer cannot distinguish between being in free fall and being in empty space. A firewall makes that crossing violent, observable, and devastating. It breaks one of the foundational pillars of modern physics. But without the firewall, quantum mechanics breaks. We cannot have both. We cannot discard either. And we have found no third option that resolves the contradiction cleanly. Every event horizon in the universe may be a wall of fire, or it may be nothing at all. We cannot tell from the outside. We will never be able to tell from the inside. The answer is locked away in a place nothing can return from. Number 4. What exists before the collapse? When a star dies, when it runs out of fuel, and its core can no longer support its own weight, it collapses inward in a fraction of a second. For stellar masses above a certain threshold, that collapse does not stop. Nothing can halt it. The material compresses past the point of a neutron star, past every known form of degenerate matter, into a black hole. Here is what we do not understand. What, exactly, is happening during the final moments of collapse after the event horizon forms? But before the material reaches the singularity, there is a phase of the collapse that exists inside the event horizon, out of contact with the rest of the universe, where matter is transitioning from its final physical state into whatever the singularity represents. We cannot model this phase accurately. Our equations predict it. Our equations also break down before they can fully describe it. The physics of that interior transition, what forces are acting, what quantum processes are occurring, whether spacetime is still continuous is unknown. Something happens inside every black hole during and after its formation that we have never seen and can never see. It is happening right now. In the Milky Way alone, there are millions of stellar mass black holes. Every one of them contains a region of physics we do not understand, operating according to rules we have not discovered, producing results we cannot predict. They are everywhere, and they are opaque. Number 3 of the breakdown of quantum mechanics. Quantum mechanics is the most experimentally verified theory in the history of science. Its predictions have been confirmed to more decimal places than any other theory humanity has ever produced. It governs chemistry, electronics, nuclear physics, the behavior of light, the structure of matter at every scale smaller than an atom. It does not work inside a black hole, not because we have tested it and found it wanting, because we cannot test it there at all, but the equations, when applied to the interior of a black hole, near the singularity, produce results that are either meaningless or contradictory. Quantum mechanics assumes a fixed background of spacetime in which particles and fields evolve. Near the singularity, spacetime is not fixed. It is not stable. It is not even clearly defined. The curvature becomes infinite. The geometry becomes undefined. The background on which quantum mechanics is written ceases to exist. This means that inside every black hole, in the region approaching the singularity, we have no working theory of physics. Not an incomplete one. Not an approximate one. None. We are the most scientifically advanced civilization this planet has ever produced. We have mapped the cosmic microwave background to extraordinary precision. We have detected gravitational waves from black hole mergers a billion light years away. We have built machines that accelerate particles to within a fraction of the speed of light, and inside the object that produces the strongest gravity in the known universe, we have nothing. No theory. No framework. No answer. Number 2 of the Planck scale. There is a length so small that physics, as we understand it, cannot describe what happens at or below it. It is called the Planck length, approximately 1.6 times 10 to the power of negative 35 meters. To call it small is to fail the concept completely. It is 16 orders of magnitude smaller than a proton. At the singularity of a black hole, matter is theoretically compressed to a point with no size at all. That means it passes through the Planck scale entirely. And below the Planck scale, our understanding of space and time as continuous geometric entities breaks down completely. Some physicists believe that at the Planck scale, space-time becomes discrete, that it is not a smooth fabric, but a kind of quantum foam, a structure that flickers and fluctuates at scales we have never directly observed. If this is true, then the singularity, as described by general relativity, a true geometric point of infinite density, it cannot exist. Spacetime would granulate before it ever reached that state. What replaces the singularity in that case? We do not know. Loop quantum gravity proposes one answer. String theory proposes another. Neither has been confirmed. Neither is complete. And in the absence of a verified theory of quantum gravity, the question of what actually exists at the center of a black hole remains completely open. There is something there, something at a scale smaller than anything we can directly probe, operating according to rules we have not yet written, and it is inside every black hole, all of them, right now. Number 1, the thing we cannot name. Every entry on this list is a gap, a place where our understanding ends and something else begins, something we cannot reach, cannot test, cannot observe, and cannot explain. But there is something worse than a gap. There is the possibility that what lies inside a black hole is not simply beyond our current understanding, but beyond the capacity of human understanding entirely. In 1931, Kurt Dill proved that within any sufficiently complex formal system, there exist true statements that the system cannot prove. Mathematics contains truths that mathematics cannot reach. This is not a temporary limitation waiting to be overcome. It is a structural property of formal reasoning itself. Physics is a formal system. It is built on mathematics. And if GDL's incompleteness theorems apply, if there are true statements about physical reality that the logical structure of physics cannot derive, then some questions about the universe are not merely unanswered. They are unanswerable. The interior of a black hole may be precisely that kind of question. Not a puzzle waiting for the right genius. Not a problem requiring a better telescope or a more powerful accelerator. A region of reality that exists, that operates, that contains, and that the structure of human reasoning may be fundamentally incapable of accessing. We built science to answer questions. We built mathematics to describe reality. We built language to give shape to things we do not understand. None of those tools reach inside a black hole. Whatever is in there is not waiting to be discovered. It simply is. Beyond language, beyond mathematics, beyond us, and it always will be.